This is section 9.4. We're going to look at proportions in triangles. Theorem 9.4 says if a line is parallel to one side of a triangle and intersects the other two sides, then the triangle formed is similar to the original triangle. So you're going to see this diagram a lot over the next few sections. We have a big triangle with a little triangle inside of it. If these two sides are parallel, that forces these two triangles to be similar. Here's the reason. When you have parallel segments or lines, you're going to get congruent angles. These angles are corresponding angles. Since the lines are parallel, they're congruent. Likewise, these ones are as well. Now, this angle A is actually the same angle for both triangles. So these are definitely similar triangles by angle. So you're going to see a lot of triangles inside of triangles with parallel marks here. If it helps you, you can separate the triangles and solve the problem from there because you're going to have similar triangles. So here's an example. You have a triangle inside of a triangle. These two sides are parallel. So we know this. We know these angles match. We know these angles match. And this angle S is obviously in both triangles. S to V, that's this side, the left side of the smaller triangle. It corresponds with segment SR, that's the left side of the big triangle. What corresponds with segment RT? That's the right side of the big triangle. Look at the marks. RT, V, W have the same marks. So we're matching up corresponding parts. These pairs of sides are proportional, is what that means, remember. S to T, that's the bottom of the big triangle. That goes with the bottom of the little triangle. Look at the marks, they match. S to R, that's the left side of the big triangle. What does it go with? It goes with the left side of the smaller triangle. 3 marks, 1 mark, 3 marks, 1 mark. Let's try it with some numbers. We want to find this value of X. So we need to write proportions. We have a triangle inside of a triangle. These sides are parallel. So that theorem tells us that these two triangles are similar. So we know that angle is obviously the same as itself. This angle is congruent to this angle. This angle is congruent to this angle. That gives you some reference so you know what goes with what. We want to find this value of X, and that comes from the bigger triangle. That's the bottom of the bigger triangle, notice. It goes from an angle with 1 arc to an angle with 2 arcs. Well, on the little triangle, the thing that corresponds with that is the 8. If we look at the left side of the bigger triangle, the left side of the bigger triangle is 6 and 3 together. That's 9. The left side of the little triangle is 6. We're going to cross multiply. We're going to take 9 times 8, which will give us 72. Then we're going to, whoopsies. Then we're going to divide by 6. 72 divided by 6 will give you your answer. And that's 12. You can double check your work. This is one way to do it. If you didn't like how we set this up, you could draw your two triangles separately. We know that's X. We know this is 9. Be careful. That's this side. Let's compare that with that 6 and that 8. So if you didn't like just pulling the numbers off, like we did the first way, you could draw them separately. 6 to 9. Is that the same thing as 8 to 12? Yeah, they're both 2/3, so that is your answer. Same diagram. Triangle inside of a triangle. You have two parallel sides. That forces the triangles to be similar. So we know these angles are the same. We know that these angles are the same. We know that angle Q is the same as itself. I'll draw them separately. Maybe that's just the better way to go about it. Little triangle, big triangle. Bottom of the big triangle is what we're looking for. Right side of the big triangle we know is 8. Notice how this guy times 2 gives you 8. This guy times 2 is going to give you that, right? 4 to 8 equals 5 to x. So we know that x is 10. 40 divided by 4. We'll look at this theorem in the next video.